This lecture covers how to do basic statistical analyses in SAS. So, as I mentioned in class, I don't see this as being a course in statistics at all. It's much more of a computer science-y course. My intent is not to teach you new statistics in this course, but I would like for you to be able to do everything that you know how to do in SPSS in SAS. So this first slide gives an overview of what I want to talk about in this lecture. So if you think back to fall, when you took the first stats course, we talked a little bit about z-scores, standardizing data, and we also talked about ranking cases. So that was way back in about week 3. So the equivalent in SPSS to get z-scores was standardize, descriptives, and the equivalent for finding deciles and ranking cases was transform rank cases. From that we moved on to statistical inference after doing some probability theory, and we talked about confidence intervals in chapter 9. Well, you do those in proc means and univariate and SAS. Now we moved on to chapter 10, started out by doing some single sample t-tests and some paired sample t-tests. You use either univariate or t-test in SAS to do those. Towards the end of chapter 10, we got to the independent sample t-test, which you continue to use proc t-test for. Then in fall, we did chapter 17, which was the Chisquare Test of Independence for a crosstab. You do that in proc freak. In winter, you had the second stats course, where you did things like regression, logistic regression, factor analysis, cluster analysis, and you may have done ANOVA. If not, I'll give you one slide on it. So let's walk our way through all this. By the way, if you click on any of these links, you're brought to the SAS website. Let me bring that down for you, giving you help on any of the procedures that you want. So here is everything you ever wanted to know about the t-test procedure. All right. So how do you find z-scores in SAS, and for that matter rank cases? The answer is you use Proc Standard. So if you say Proc Standard, give it an input data set name. Maybe I'll make this a little bit bigger for you. And you need a data set, and then you have to give it an output data set. So the results are going to be stored in this output data set. So for this example, I'm going to use the employee data set that we've been talking about, and I'm going to put it in work. So we're not going to overwrite my original file, but we'll create a new one. Two options that you will want to use with Proc Standard is what do you want the mean to be, and what do you want the standard deviation to be. So almost always it'll be mean 0, standard deviation 1. Occasionally you only want to mean center the data. In that case you would omit the standard deviation equal to 1 argument. You just list the variables. Now this overwrites the original variables, and in the employee data set here, what you'll see is that if I compute the mean and the standard deviation, the mean is essentially 0 and the standard deviations are 1. So it looks like Proc Standard does what I thought it would. Now let's go on to ranking cases. So we use this in my class to find quartiles, and you probably used it in Frank's class to find deciles. Let's go to the employee data set. We're going to rank some cases there. Again, I have to send the output somewhere. Let's send it to work.employee. Then an option that you want is groups. Groups specifies the number of quantiles. So if I say groups equals 4, that's going to divide it up into quartiles, 4 groups. Okay, two statements after that. So the var statement lists the variable that you want to find quartiles of, and then unlike Proc Standard with Proc Rank, you create a new variable containing the deciles. So you put that in a rank statement. So I want to put the quartiles of age and years into a new variable called age4. Now let's run proc means. I'm going to have a class statement on age4, and we'll run the min and the max for age. All right, so what you're going to see is that the first quartile is from about 30 to 39. The second quartile is 40 through 45, third quartile 46 through 50, and the last quartile 52 through 61. So it looks like it did what I thought it would do. It divided this up into 4 roughly equally sized groups. These ends indicate the size of the groups. And they're not exactly equal because of ties. Okay, let's move on. Chapter 9 in Siegel was all about confidence intervals. So in SPSS we used descriptives explore to find confidence intervals. In SAS we're going to use either proc means or proc univariate. So if you want to use proc means, the two arguments that you really want are LCLM and UCLM. It stands for upper confidence limit for the mean and lower confidence limit for the mean. And let's just go look at what you get when you do this. So I happen to run it for two variables, age and female. So female is going to be a 0, 1 variable. And I printed out the mean, the standard deviation, the standard error, and here are those confidence intervals. You can also get it in proc univariate if you use the CI basic option. So I've provided just the output for age. I didn't do the one for female. But let's take a quick look at this. So the confidence limit for age is minus 43.8 to 47.26. And what you will see is that that matches what I got upstairs, 43.30, 47.26. So proc univariate gives us exactly the same thing as proc means. I tend to use proc means. Moving on to chapter 10. Next thing we did was the single sample and the paired sample t-test. How do you do those in SAS? Proc univariate. So if you run proc univariate, let's test whether the mean of age could plausibly be 43. Now if you go back to the previous slide, 43 is not in the confidence interval. It's outside the confidence interval, therefore we should expect to reject that null hypothesis. Okay, how do we do this? Well, you add an argument that specifies the reference value that's in the null and alternative hypothesis. So that's 43 years. And so here you go, test of location with the mean H0, mu equal to 43. SAS gives you a couple things. So this first line right here gives you the information for the t-test that we did in class. And so you'll see the p-value is less than 0.05. We reject it. We expect to do that because remember 43 fell outside the confidence interval. The next two rows give some non-parametric tests, which you did not do. I believe those are covered in chapter 16, but I wouldn't worry about them for now. Let's move on to the paired sample t-test. Now the paired sample t-test is where you have two measurements on each sampling unit. So we did a problem back in fall from Siegel. It was called the lie detector problem, where remember we measured your stress level when you told the truth and when you told a lie. So this was an example in class. And what I told you was you compute the difference between the two measures and then just do a single sample t-test on it. So the point is you've got to add this line that computes the difference. Then you run proc univariate on the difference variable with a mu naught equal to 0 option. And this p-value matches exactly what we got when we did it by hand in class, as well as what we got when we used SPSS. And I refer you back to your class notes from 451. Moving on to the last part of chapter 10. The last part of chapter 10 was the independent sample t-test. To do this in SAS, we're going to use proc t-test. So let's ask this question. Do males and females have the same mean income? So H0 mu female equal to mu male, where mu female is the true mean salary for females. The way you specify that in SAS is you drop the independent variable into a class statement, drop your dependent variable or variables into a var statement. Now the output, the text output is not very user-friendly, but here it is. What you'll see is you have two rows, one for males and females. You have their sample sizes. Here are the means. It looks like men make about 10,000 more than women in this data set, 9,000 more. Standard deviations of within the groups, standard errors. Coming down, this gets kind of confusing. We could look at the test for the equality of variance. So this is testing whether the variances are equal. P-value is significant, so we would reject the null hypothesis of equal variances. We go look at the standard deviations and they're pretty different up here. So it's not surprising that we reject that hypothesis. Now, let's go back up to here. Here we have our equal and unequal variance rows. We're going to assume unequal variances. Here's the p-value to test the difference. So the p-value is highly significant. We reject the null hypothesis of the equality of means here and conclude that men have higher salaries than women at this company. You could also do this with Proc GLM. We'll come back to that on the next slide. So, actually, 2 slides from now. Let's talk about Chapter 17, since we're going to finish up what I did in my class. Chapter 17 talked about the Chisquare Test of independence for crosstabs. So let's run a crosstab of gender versus the training level. Here are some useful options. Let's suppress the row and column percents, suppress the joint probabilities. Expected gives us expected cell counts, which would be like the unstandardized residuals in SPSS. I'm sorry, those gives us expected cell counts. Deviation gives us the unstandardized residuals. Then the chi-square option requests that we get a chi-square test of independence. So here's the output. The chi-square test of independence gives us a p-value of 0.13, not significant. Can't say that there's any relationship between gender and training level. So can't reject the null hypothesis of independence. Moving on,